Okay. All right. I hope everyone have the file already. Let me try to share my screen and then proceed it from my side. You guys can test out the test case as well. So the first thing I do, so the test case is coverage merge. So the first thing I do is let's bring up the make file. Then we can see the different options of coverage merge and then the coverage collection option needed. So everything you can refer from here. So next time, if you want to do coverage collection on any of your design, you can also refer back to this test case as it has most of the coverage collection option on already. So from the make file, let's see make all first. So make all, and how do I do make all? So make all one we do compile op and also sim. So the difference is I have two sets of test bench and also my different set of top. So all one I compile top.sv and then tb.sv. I put it in a different set of work library and I specify it with work all one. So it will create this physical library all one. And then my VOP, I do VOP my test bench, which is my top module. And then the same, I'll have to output optimize name, and then I plus cover equals to BCEFFT, so that I can collect all of the code coverage here. And because I'm also collecting this a lot of stuff, so I'll use debug cell and then plus design file to generate the database. And here I have to use specify my work library in the first work library as well. And then on sim, so I do vsim dash coverage is a must if you want to collect coverage. And then your optimized DU name dash C for console, and then you do. So usually you will do run all, and then on coverage save, you have to do coverage save so that you can generate your UCDB. So coverage save all one.ucdb, it will generate all UCDB for this simulation, and then you quit. Then on QFDB, you can add a logging for signal memory equals to all. So you have to specify the work library here as well because all of the compile and optimize module are inside this work library. So the same with all two. So the difference is only I compile different system verilog file, which is top2 and also tb2. So this will create all2.ucdb and then there's a all1.ucdb. So let's do make all. So I have make all. So let's see what's deposited. So I have all1.ucdb and also all2.ucdb. Then now I would like to view my coverage collection in our debugger. So how do I do it? I use this command, vis view cov all1.ucdb. So this will be able to bring up the coverage collection details without having to actually use the design bin and also the wave file as well. So I have already to make commands of make cov1, view cov1. Let me share. Then it will bring out the coverage collection for the simple test case that I did. So if you double click on this instance in stop, you can see the total number of coverage being toggled. So right here, I have filtered it to change it on toggle coverage only. So if you can see this outlane WR data valid, so this is a 4-bit logic. So you can expand this outlane WR valid and then you can see which are being toggled. So bit 2 and bit 3 is being toggled, and it is only being toggled on 0 to 1. It's not being toggled on 1 to 0, so it's only 50% for each, and the total percentage for this out lane valid is only 25%. So let's go back to the previous one and let's check on view cuff 2 on my second UCB, view cuff 2. So again, we are interested in the same signal point, which is this instance and then outlane WR data valid. So again, we expand it and then we'll see which bits are being toggled. So for UCB2, we are toggling this bit 0 and bit 1, but they are only being toggled from 0 to 1 for bit 0 and 0 to 1 on bit 1. And the same, it's because it's only 50% for both of this, and it's 25% for the total coverage for this outlane WR valid. So now let's try to merge them together. So if you can see from the make file, I have already have the merge command here. So in this case, both of my design unit are the same. I'm just toggling different test bench. So for example, my test bench, I'm toggling it to be 4-bit of 1100, and the other one toggling 0011. So there's not much changes in the DU. We can use vCover merge without the adaptive flag. So I can do make merge, which is, oops. So I can use make merge, which what it does is to merge, and then it gives the output of merge.ucdb, and then I merge these two UCDB. Now we do make view cuff 3. This is to view my merge.ucdb. Okay. Then we go to the same instance and we check on this WR valid. So after merging this outlane WR valid, we can see that it's being toggled all of the 4 bits, and all of the 4 bits are being toggled from 0 to 1, which leads to 50% for each of the bit, and the total percentage increase from 25% to 50% here. So this is how you use a coverage merge easily. Right? So you can play around this coverage metrics and see from this view curve there's a view. Because we didn't load the design database and also the load file, most of the view you can view are from this coverage tab point here. So any type of coverage that you would like to see, also let's say we go to coverage summary. So we have all of this coverage summary. We can actually double click on this on, let's say, conditional. So these conditional are not being met. So if we want to hit a better coverage on conditional coverage collection percentage, we will have to meet this condition. And go back to the coverage summary again. So branches, we have 2 out of 4. Let's see what branches are we missing. So branches, we can also double click on this branch. So it's 15.1. We are missing this if statement. So we are hitting the false, but we didn't hit what happens if it hits. Let's go back to coverage summary and toggles. There are more here. So we have a lot of bits from this data out which are not being hit. So if we want to hit this bit, we can check from where we are hitting it from. And then let's see what else can we check from here. So I've also included the report file to generate a text report so that we can have a simplified way of looking at the report. So let's go back to the terminal. Let me close one of the UCBs. So if we go back to the terminal, we can use this report, make report to generate the report. So how we generate the report is to use vcover command, vcover report, our merge.usdb, and then all code recursive, and the report name is top.report. So let's make report. So once we make report, we should have this top.report generated. We can check it here. And then on my VM, I use gedit. So gedit top.report. So we can see the coverage report from the small test case. So this is a recursive coverage report summary by instance. So there's two instances, which is instop and also instb. So for instop, we have all of these branches, conditional statements, and toggles that are shown the total percentage for each. And because this is a recursive report, we include the instance from instop to the TV, and the percentage coverage is the same. So if you want to generate HTML report, we can do that as well. Let's see, how do we generate this HTML report? So HTML report is basically the same. We put it in the make file as well. We do vcover report, and then our merge.ucdb, and our output cuff.html. And then we just have to add another h-html. Let's try doing this. Make HTML. So we check the directory again. We should have this cuff.html. We can use Firefox to open up this HTML. We should be able to open up the Firefox, but I'm not sure if I configured Firefox in my VM. But you guys can try on the HTML report using Firefox to open it up. Right. Let's see what else we can check from the debugger itself. Let's check coverage exclusion. So in stop, let's open up this data out. That's a lot of bits, 8 bits from 7 to 0. So the ones that are not being hit, so for example, 4, 5, 6, and 7, if we want to exclude it out, we can simply highlight it and then right click, and then we click on exclude selection. So once we click on this exclude selection, it will actually go into this pending exclusion list, which is up here. Let me pull it up a little bit. Okay, let me just maximize it. So we have all of these 4 data bits data out are pending for our execution. So we can either right click one of it and then we execute selected commands, or we can also click here to execute all of the commands. Let's say we click this one and then there's nothing in the pending exclusion list anymore. We minimize it. So again, we go back here, go see total coverage, and then we check our data out now. So right now, this data out bit 4, 5, 6, and 7 are grayed out. So it's being excluded. So we have increased percentage compared to previous data out. And if you want to cancel this exclusion, it's the same. We can, let's say I want to cancel 2 of this. Then I right click, cancel selected exclusion. It will go into exclusion list, and then let me double click it. So click again. It's now only pending. And if I remove the selection, it seems like we have to execute the pending exclusion list as well so that it will be cancelled out. All right. Let's see what else we can check from here. Let's see. If you guys have any questions on coverage collection, you can let me know as well. So back to saving pending exclusion list, we can do this. Let's see. Let's put this into exclude selection items. And then we highlight both of these, we can right click, and then we can save this pending exclusion file so that we can quickly come back to it. It will be saved as a .do file. So you can save it as a exclusion.do. And the next time you bring up this debugger, you can quickly use do command, and then you can exclude it quickly as well. All right, is there anyone having trouble with the lab, or did you manage to navigate around on the coverage? So let me show you one more thing. Let me purposely edit the source code file. So for example, right now my due is exactly the same, but I can also do something like this. So always, I add another always block. I put x equals to data in as well, because x is my output. So whenever there's a change in data in, then I'll change as well. So now I'll make all so that I can compile it again. So right now, by right, if I merge both of these UCDBs, it will have a warning because it is different in terms of there's a slight change in DU. So I have compiled it both and I have both of the UCDBs again. So all one and all two. Let me try to merge it without adaptive flow. Let me merge. Okay, because there is a slight change in the DU, there will be a warning flag by Cresta saying that there's a source code mismatch when merging this all2.ucdb. And it will also show it will skip code coverage merge for the design unit. So right now, if I do adaptive flow dash adaptive merge, of my merge.ucdb, add also adaptive to my VOP. Let's see, view of tree. So if I use dash master option, it will use my latest UCDB design unit. So we have this included in. But because of this version that I'm using is not the latest one, so the adaptive merge for that code coverage is not being supported yet, but it should have supported in the latest build of the visualizer and also Questa. But for now, I can use a master merge where I merge the latest design unit with dash master command, which is, for example, like this. And then it will be reflected in the USDB as well. All right, I think that's basically all for the coverage lab. Yep, let me know if there's any issues or trouble getting the coverage collection up. So right now it's 4 already, so I reserve 30 minutes for Q&A sessions. If there's any questions you guys can ask now, then I can try my best to answer your questions. So from 4 to 4:30, it's only Q&A. If you guys don't have any questions, I'll still be around. But if you guys don't have any questions, I think today's session will be only up to this for today. Then tomorrow we'll continue with power-aware simulation, clock domain crossing, and also X propagation. Yep. If you guys have any question, you can ask now. If not, then we can meet again tomorrow. But I'll stay here until 4:30 4:30 p.m. Yeah. Thanks for joining, guys.